channel. Thanks for subscribing to our channel. We really appreciate you. Today we quickly want to take a look at the Neco chemistry practical. That is what we want to talk about today. We will talk about the chemistry practical question. We'll quickly take the practical, the quantitative analysis as well, that is the titration, which most times is the first question you come across in the practical. So we take the practical question, the titration, and then we solve one or two questions after getting out the table from the practical. Quickly, for every student that will be taking the exam, let me quickly say this. There are certain things that you need to be very, very careful about or be aware of in the course of writing the exam. These are guidelines that will help you in getting better grades. One of them is, under no condition must you put down your answers in pencil. No writing of pencil or no writing with pencils into your answer sheet. Everything you want to write must be done in ink. Also, you try as much as possible to avoid arithmetical errors. It is very, very important because this can score you down. Another thing is, make sure you do not use the wrong use or the wrong unit for any answer that is to be given. Any answer that is given should be in the right unit. You must make sure you use the right unit. But in case you are unable to write put down the right unit, it is important that you try as much as possible. If you cannot remember the right unit, it is better left undone. Don't write any unit, as that will probably be a saving grace than you putting the wrong unit. And then in the course of writing or putting down your table, I mean the titration table, please try as much as possible not to erase it or cancel rather. Don't cancel your table in your answer booklet. It is very, very important. And lastly, in reading your burets, try as much as possible to make your answers to be in the nearest whole number. It is very, very important. So having said that, we'll quickly go straight into the titration. Now, for this year's Neco chemistry practical, the chemicals that you have been given, we have been asked to use H2SO4 as the acid, and then the sodium tricarbonate as the base. We have been asked to use tetrasulfuric acid as the acid, and then the sodium tricarbonate as base. So those are the things that we'll be using for this particular titration. And because this titration is used or is comprising of a strong acid and a weak base, we'll be making the use of an indicator which is methyl orange. Methyl orange is the most suitable indicator for this particular type of titration. So that is what we will be using for this titration. Now, we quickly want to do this. So let us start from there. Okay, let me rinse this to avoid all types of impurities. Okay, so I am putting here my A. I have my A here. And here I have my B. So try as much as possible to be careful when carrying out your practical. So this is my funnel which has been rinsed, but let me rinse again. So make sure your funnel is very, very clean. So I have my funnel there, and this is my acid. So I'm pouring my acid into the burette. So my acid goes into the burette. Okay, this is my acid. So I have poured my acid into the burette, so I need to make sure it is at a good mark. So I need to zero it. So I should try as much as possible to watch the lower meniscus. Okay, so that is done. Make sure you remove your funnel from the tip of the burette. It is very, very important. Leaving your funnel there could add more to your to the substance in the burette. So this is my base now. Alright. Okay, I have the content of my base emptying into the conical flask. So we'll just have a couple of concordant readings. Let's say 2-3 readings, and then we try to see if we can move from there. So here is the way put the base there, so we don't match them up together. So I'm adding my indicator to the content of the conical flask. 2 drops of indicator is is all I need. So that gives me this golden yellow color, and then I can start to run my content. After gently stirring it, I can add my content from the from the beaker. So I add my content and I start to stir. So that is what I'll be doing now, and I'll be trying to watch out for a change in color. So I'm watching out for a change in color. I'm already seeing slight changes in the color. So the moment I notice that it is okay, I'm still seeing, yes, that started changing, but I'm still seeing some traces of golden yellow in it. So let me add a little bit of the acid into it. Okay, this is what I have now. So at this point, my reading is, I have it to be, my reading right now is 19.9. Alright, so this is how to draw a good table. Let me put the table here. We have a table like this. Alright, I have first reading. Here I have the second reading. Here I have the third reading. This means I should have done this. Here I should have my rough. It is important that we have rough as well. So here I am having my initial reading. And here I am having my final reading, and this is going to be my volume of acid used. Volume of acid used. Alright, so let us start. The first one I started from 50.0. So I have my final to be 19 points. Sorry, I'm using a direct 50 centimeter cube direct. That is why I said that. So I have my final reading to be this, and then let us go to the second one. So this is going to be okay. We'll come to that to actually talk about to calculate it. So that is that about the first one. You can see the color that it has given us. So let us go to the second. Let me quickly rinse this. Right. I have rinsed. So let me. Alright. So we are having this. I'm emptying the content into the conical flask. So let me top this up. Because Neco has asked us to give every student 150 centimeter cube, that is 3 times the volume of the rate. So let me zero it now. Alright, there's a zero mark now. So let me see. This is running out. Alright, so I've completely emptied the content of the pipette into the conical flask, and I've gently stirred again, like you can see here. So let me start running the content into the conical flask. So let us see. Let's see. It has started changing, but I'm still seeing some traces of golden yellow inside of it. So we'll have to add a little more. Alright, you can see what we have here now. So this is another color. So this is the color change. So the right now is 19.5. 19.5. Remember we moved back to 0, so we have 19.50. So let us take another reading. Let's take another reading. It's important that the difference between your two readings must not be more than 0.2. So you need to have that at the back of your mind. Alright. So we need to zero this carefully. Alright, so I'm emptying into the conical flask now. Let me fill up my burette once more. Alright, so I have this done. Alright, so the content of my conical flask is empty right now. Sorry, the content of my pipette is empty. So let me add 2 drops of the methyl orange. I've added 2 drops of the methyl orange. So this is what I have, the golden yellow color like we had before. So let me now add my acid run into it. So I'm running my acid into it now. You can see the color change that is being experienced. That has been experienced in the first and second, so let us see what happens in the third too. Alright. So you can see what we have. You can see the color change now. So this is our end product. So the mark we have here is, we have it to be 19.5 again. I have it to be 19.5 again. So let's take one more reading. So we use that as our grading. Sorry, let me rinse. So, as usual, let me top this up. Alright. Okay, so I've zeroed this as well. Now let me add my indicator. So it's 2 drops of indicator, 1, 2. So after adding my indicator, I have this golden yellow color. So I have stirred gently. Let me now run my acid to it to get the final reading. Now, you probably may not be able to get the reading instantly because this is not new to me. That is why I'm able to get it the way I'm getting it. But for you who probably you're doing it for the first time, you probably may not be able to get the answer spontaneously like I am getting it, or do you have exact answer like I am having it. So you try as much as possible to be careful. The first color change you notice is where you need to stop. So once you notice the color change, it probably will be appearing and disappearing. This has appeared, being shown, and it has disappeared again. So I will keep adding my acid into it until I have a color change that is distinct, like I have now. Okay, I'm still seeing some yellow or golden yellow color in this. Let me add little more to it. Okay, so I can see this now. So let me see what's my Alright, I still have 19.50. So in some cases you could have a difference in some of these values. Like I had here, this one was supposed to be 19.8, sorry, 19.8, the rough was 19.8, and now I have the others to be like this, 19.50, 19.50. So if I have all of this, my average, my volume of acid use for this one will be 19.80, that is 19 minus is 0, and here we are having 19.50, 19.50, also 19.50. So the volume, average titration value now, average titration value, remember that I said it must be with a mark of no more than 0.2. So all of these ones, 19.5, 19.5, 19.5, they are different from 19.8 with a margin of 0.30. So we cannot use this one, and most times we don't use rough. But since we have all of these ones to be the same, we have what? 19.5 plus 19.5 plus 19.5 divided by 3, because we are using 3 readings at this moment. If it were to be 2, let's assume this one was 19.4 and this one is 19.3. That can also happen. If you have 19.5, 19.4, 19.3, you also have what? Margin of not more than 0.2. You can use the 3 of them, then you divide by 3. For what we have here, our average titration value is going to be 19.50, because when you add everything and you divide by 3, you see we were getting 19.50, and this is going to be the volume of our acid used, that is VA. So we have it to be centimeter cube. So that is that about that. Now that we have been able to get this out of the way, let us now quickly take a couple of questions. So let me put this aside and we quickly take 1 or 2 questions. Okay, so now, peradventure you are given some questions like you being asked to talk about or to calculate the concentration of probably the acid or the concentration of base. It depends on the parameters that you have been given. The parameters you have been given will determine the type of formula that you will be using. So let us quickly put down a few formulas that will be needed in solving some questions. Okay, let me put them down here, after which we continue. Okay, here I have formulas now. Formulas. Okay, you could be having 1 molar concentration. Now, molar concentration is in moles per dm cube. Molar concentration is in moles per dm cube. And we have the formula to look like this. The formula for molar concentration is mass concentration, which is in grams per dm cube, over we have molar mass. Molar mass is in gram per mole. That is the formula for the molar concentration. Now, from molar concentration, we can actually get out the formula for molar mass and the formula for mass concentration. Example, if you need the formula for mass concentration, it is going to be, we have it to be molar concentration multiplied by molar mass. And if what we are looking for is molar mass is going to be equal to, we have it to be mass concentration over molar concentration. So it is very, very important that we understand these formulas. We could also be asked, depending on the question, like I said, we could be needing this. This is another formula, CAVA over CBVB, then number of moles of acid over number of moles of the base. This is another formula that we probably be needing. We could also be needing percentage purity. If you are asked to calculate the percentage purity, what you'll be needing is this. Percentage purity. Now, because it is percentage, it is going to be what? 100 minus, because the percentage is over 100, so it's going to be 100 minus the percentage of impurity. Percentage of impurity. So depending on the question that you are being given, that will determine what you will be using. So the question will determine the type of formula that will be used. So before we go further, let us quickly write out from the equation that is being given, or the substance that is being given. Let us draw out, because some questions will need you to give. That is the way we can get our number of acid, the number of moles of acid and number of moles of base. Like I said, you have been told to use H2SO4 and sodium triacylcarbonate. So this is what we'll be having. We'll be having, let us draw that out. Let us quickly write the equation for the reaction. So we have H2SO4 plus sodium triacylcarbonate. I think this case will not be enough for that. Let me put it here. We have H2SO4 plus sodium triacylcarbonate. Now this is going to give us, we have sodium, SO4 plus CO2 plus water. Yes, this is a neutralization reaction. We are having our acid being neutralized by the base, or the base neutralized by the acid. Eventually, we are going to be having salt and water. Here we have our salt and water. So this is what we have. So if we look at the reaction, I think the reaction is balanced, and it is giving us our acid to our base in ratio 1:1. So since our acid to our base is in ratio 1:1, our NaNB will be what? 1:1. I believe that is clear now. Alright, so having taken this down, let us quickly look at a couple of questions. Please permit me to put off this from the board. Okay, so we have said that the volume of our acid VA is 19.50 centimeter cube, and then we have our Na to be 1, our Nb is also 1. So let us see. In case you are given the question to have some parameters, like, let me just list out few parameters here depending on the kind of question that you probably be asked. In case you are asked, if you be asked questions on percentage impurity, definitely you will be given percentage purity and the rest of them. So let me just list out a few parameters. So let's assume for the A, you are given the percentage purity. Percentage purity for A, percentage purity for A is 98%. 98%, then specific gravity. Specific gravity is 1.8. Yes, that is the gravity for acid, for the acid, which is the H2SO4. Alright, let's assume that you are given mass concentration of A. Let's assume you are given, okay, let's not go there. Let's assume you are given the molar concentration. Yes, you can even calculate the molar concentration of A cell. So let us quickly calculate the molar mass of A. If we have our A to the H2SO4, let us do that here. H2SO4, what is going to be our molar mass? Our H is 1, our S is 32, and our O is 16. So we have 1 times 2 plus 32 plus 16 multiplied by 4. Yes, that is what we have. So 1 times 2 is 2 plus 32, then 16 times 4 is going to give us, we have 50, okay? I'm not just waste our time, we have 16 times 4, which is going to give us 64. So adding all of this together, we're having 128. So the molar mass for molar mass for A is 128 grams per. Okay, the molar mass grams per mole. Yes, that is the molar mass for our A. And then for our B, this is A. And for our B, carbonates. Okay, we have N. Okay, let me include this here. Our Na is 23. So we have 23 times 2 plus carbon is 12 plus our oxygen, which is 16 times 3, because 16 oxygen is appearing 3 times. So we have 22 times 3, which is going to give us 46 plus 12, and then plus 16 times 3 now is going to give us 48. So all of this together, 48 plus 46 plus 12 is going to give us 106. So that is for base. So molar mass for base, this is for acid. So molar mass for base is, we have it to be 106 grams per mole. So that is that. Now, let's assume you are told to calculate from the question that I have here, calculate the average volume of acid used. Yes, from our table we have been able to calculate the volume of acid. That was when we calculated the average titral value. So from our first titral value, the second and the third titral values, we were able to get 19.5, 19.5, 19.5, and so we use those three because they are what? In concordance to one another, and they do not have more than 0.2 difference to one another. So we were able to use those three, and then that gave us 19.5 as our average volume of acid used. So that is number one. So number two said write the equation for the reaction between A and B. That was what I wrote earlier on. So let me just be putting them down. A1 volume of acid used. Okay, I think that is too far. Let me put it here. Volume of acid used. The volume of acid used, we have it to be 19.50 centimeter cube. 19.50 centimeter cube. And then the next question said we should give a reaction for an equation for the reaction. That was what we did earlier on, which was what we were able to use to get our NaNB. So this is the reaction. We have H2SO4 plus Na2CO3 to give us Na2SO4 plus CO2, and then water is being released. So that is the reaction for the reaction for the equation, or for the equation for the reaction rather. And then the next question there says, from the results and information provided, you should calculate the concentration of A in moles per dm cube, then concentration of B in moles per dm cube. Now, let us look at this. From the questions we have VA, we have NaNB, we have the molar mass, then we have VB too. VB is 25 centimeter cube, because that was that's the size of the pipette that we used. So, like I was saying, depending on the type of parameter that you are being given, that will inform the type of formula that you'll be using. Let's assume we're given this information. Let's assume we're given mass concentration to be mass concentration of A. Mass concentration of A to be 2.2. And then, let me use the molar mass. Okay, we have calculated the molar mass. Okay, all right. So if we have this, we have formula, like I said earlier on, is molar mass equals, okay, let me start with this one. So draw it down from there. We have molar concentration to give us mass concentration divided by molar mass. So the question is now asking us to calculate the molar concentration of A. So we have the mass concentration to be 2.20. If we have the mass concentration to be 2.20, I think we will be able to get out our answer, which is going to be the molar mass. Alright, so let's see what we can do. Molar concentration, we'll be having it to be, we have the mass concentration to be 2.20 divided by our molar mass. The molar mass for acid that we calculated, H2SO4, we have it to be 128. That is the molar concentration. And the molar mass for acid. So from this now, we'll be able to get out the molar concentration for acid. So 2.20 divided by 128. That is going to give us our the molar concentration for the acid. And then we have, let me see something. So that is that. And then the next one, which is going to be the molar concentration. Sorry, this one, whatever answer you get, remember it is molar concentration. So the answer is going to be in moles per. The answer is going to be in whatever answer you get is going to be in moles per what? We'll be having it to be moles per dm³. That is going to be the formula, the units for that particular answer. And then for the other one as well, we have it to be this. So the mass concentration divided by the molar mass for B now. So for B, okay, I didn't put, okay, we have the, okay, it's unfortunate that I put it down here, which is the molar mass for B. So our molar mass for B is 106. So if we have a molar mass for B, and then we are asked to calculate the molar the molar concentration for B. So the molar concentration, paraventure were given if we were given the mass concentration. For this example, let's assume the mass concentration is 4.8 grams. If the mass concentration is 4.8 grams, so we have 4.8 grams here. So 4.8 grams divided by 106, that will also give us a value which is going to also be in moles per dm³. So I want to believe that you understand what we are talking about. Now, you could, in case you are given, okay, let us see another instance where you are given, or we have the VA, okay, from our acid, from our titration, we have our VA, we have our VB as well, we have NA, NB, we have VB, and then let's assume we're given this. Let's assume we're given the molar concentration for, we're given the concentration for B, CB now. Let's assume we're given CB and we're told to find the CA. That is, if we do not have some of these values that we're trying to get now, if we didn't have those values, we're given some just this. We have the volume of acid from our titration, we have the volume of base from the content of the pipette, then from the reaction we're able to get our NA, NB, and the reaction has only given, the question has only given us either CA or CB, and we're told to find the other one. Let's assume our CB, we were given our CB to be 0.024245 grams grams per mole. Or sorry, mole per dm cube. Mole per dm cube. Let's assume that is what we were given for our concentration of base. Now we are told to find the Ca. So for this part, this type, since we do not have the molar or whatever anything, what we'll be needing is going to be CaVa over CbVb NaNb. So this is the formula that we'll be needing for such. Now, if we look at this, this is what we will do. We have our Ca already to be this okay, the Ca is what we are looking for. So this is what we first of all do. We cross multiply to have this CaVaNb equals CbVbNa. So this is what we get. And the resultant of this, let me put it here please. The resultant of this is going to be, since you are looking for Ca is what you are looking for. So the resultant will just come in here to write, we have Ca equals everything here, CbVbNa over, we have VaNb. So CbVbNa then all over VaNb. So our Ca is what we are looking for. We have our Cb, concentration of base, should be 0.0245. So we have 0.0245 multiplied by our Vb, volume of base, which is 25 centimeters. So centimeter cube. So we can just write 25 times number of acid. From our equation, our number of acid is 1 divided by our volume of acid from the reaction. And from the titration, our volume of acid that we got is 19.50, and then our NB is also 1. So all we need to do now to get our Ca is going to be multiplying 0.0245 times 25, and then we divide our answer by 19.5. So that is going to be as far as we can go today. Please practice more questions, as it is going to be very, very helpful for you. Thank you very much. Please, for those of us that are yet to subscribe to our channel, please kindly do so. Subscribe to the channel, like our content, and share them as well so that others can easily get access to them. Liking our content is very, very important. Subscribing to them will make it possible for you to get easily notified when we upload new content. I wish you all the success that you need in your forthcoming exam. Thank you very much, and God bless.